After learning on how to get the roots of a polynomial function in different ways, this time you are to graph the polynomial. But let us first learn about the y and x intercepts. So we say to find the y-intercept, we let x to be 0. To find the x-intercept, we let y to be 0. So let's determine the intercept of these graphs. We have the first example, y is equals to the quantity of x plus 1, x plus 3, and the quantity of x plus x minus 2. It is an easy item since the polynomial function is in fact form. So let us first find its y-intercept. So when we say y-intercept, we will let x to be 0. So if we have this equation as a given, and we let x to be 0, we rewrite the equation as x will be 0, and therefore we will have the value positive 1, positive 3, and negative 2. Afterwards, all we need to do is to multiply. 1 times 3 times negative 2 will give us negative 6. And we say that y-intercept is negative 6. And the graph will pass through 0, 6. In graphing, this is the x element and this is our y element. Since we let x to be 0, so we write it here, x is 0, and our y, when x is 0, y is negative 6. So we have the ordered pair 0, negative 6. So we also need to find the x-intercept. So we let y will be equal to 0. So if this is our equation, we let y to be 0. We write it as 0 is equal to the quantity of x plus 1, x plus 3, and x minus 2. So we will go back with our previous lesson on finding the roots. So this will give us a value of x is equals to negative 1, x is equals to negative 3, x is 2. And we say that the x-intercepts are negative 1, negative 3, and 2. So the graph will pass through the points negative 1, 0, negative 3, 0, 2, 0. These are the ordered pairs. Next example. So what if we have these quantities and we have x here outside? So first, let's find the y-intercept. We let x to be 0. So if this is a given equation, we rewrite it as x will be 0 here. This will be 0, 0, 0. Diniretso ka na. So we will have 5, negative 4, and 1. And so if we will multiply everything, this will give us y is equal to 0. And so we say y-intercept is 0. And the graph will pass through the points 0, 0. Next, let's also find its x-intercept. Let y be equal to 0. So if this is the given equation or the polynomial, we rewrite or we let y to be 0. So we write it as 0 is equals to x times the quantity of x plus 5, x minus 4, and x plus 1. So our x here will be 0, x here will be negative 5, x here will be positive 4, and x here will be negative 1. So we say that the intercepts are 0, negative 5, 4, and negative 1. So the graph will pass through the points. We have 0, 0, negative 5, 0, 4, 0, and negative 1, 0. Third example, what if the given polynomial is not in factor form? Let us find its y-intercept. So we let x to be equal to 0. So this is the given polynomial. So if x here is 0, we write it as 0 raised to 2 plus 8 times 0 plus 7. 7 here is constant, no variable. So we will have 0, 0, and plus 7. So y here is equal to 7. We say y-intercept is 7. The graph passes through point 0, 7. Now for the x-intercept, we let y equal to 0. So if this is our equation or our polynomial that is not yet factored out, we need to factor it out first so that we can have the intercepts. So I let here y to be 0. So we will concentrate with the constant that is 7. What are the factors of 7 that if we will add will give us 8? So what I have here is x plus 1 and x plus 7, where 1 and 7 will give us positive 8. So the value for x here will be x is equals to negative 1, x is equals to 7. So the x-intercepts are negative 1, negative 7. The graph will pass through the points negative 1, 0, and negative 7, 0.